are looking at Unit 3, Day 2. We're talking about functions. Today we're going to focus on domain and range. To start off, I just have a number line here. With this number line, we have an inequality because there's shading in this number line. It's a little hard to see. It's not very dark, but you have a closed circle on this end, some shading, and you have an open circle on that end. Some little silly faces I draw to help clarify this is if we have open circles, then that was a dashed line on the coordinate plane. If you had closed circles, it had a line under it for like less than, dashed line, less than or equal to, solid points, and a solid line. So on set notation, it's just a way to write it. It's to show where is the shading at. So I would say like 0 is less than or equal to x, which is less than 3. So on the left end of this, I have a 0 with a closed dot, so I just put a less than or equal to sign. The shading is between these two numbers, so I put the x in the middle. On the number 3 is an open circle, so I have just a less than symbol. So that's what it's called set notation. We're going to focus more on what's called interval notation, but I want you to see both because they feel like they put both on evaluate. Interval notation would be, it's a bracket, 0, 3, and then a parenthesis. So what does a bracket or a parenthesis mean? A parenthesis means it would be like an open circle, or it could have like an arrow on the end of something going on forever in one direction. I mean, it's not closed off. There's not a stopping point. It could keep going. A bracket is where you have a closed circle, so that point is included, or you could have a solid line. Solid stopping point, we'll say. Okay, so if you look at these, how would I write this? So let's say in the picture we have closed circles on both ends. If they are closed circles on both ends of the graph, you're going to put brackets around the two numbers. It goes from one number to another number. So like this one starts at 0 and it goes to 3. If you have open circles on both ends of your picture, you're going to use parentheses. If you have a solid dot on one end, that would be a closed bracket, and then an arrow on the other end, that one's going to be a parenthesis. On this one, you have an open circle means parenthesis, arrow means parenthesis. Alright, and then this last one, you have arrows on both ends, so that could also be parentheses. Arrows mean parentheses, a closed colored in circle would mean a bracket. So, let's look at some pictures. Just a reminder, domain represents the x values, and range represents the y values. So I like to use highlighters in this lesson. If you have highlighters at home, you might want to pause this and go get your highlighters. Just using two different colors helps identify. So like for instance, this is the x-axis here. So I'm going to be looking at numbers on the x-axis. I want to figure out on the x-axis what is the smallest to largest number. So the graph, we're going to go smallest to largest. When you're doing your numbers, some people think like left to right when you're doing domain. So the farthest left this graph goes to is at -5 on the x-axis. So I'm just going to circle that. -5 is the farthest or smallest number that it starts with. Since it's an open circle on -5, we're going to put a parenthesis and then the number -5. If you go to this point stops right here, it stops at 0. So again, only looking at the x-axis when you're talking about domain. So it goes to the number 0, and on this line it's a closed dot, so I will put a bracket on that. So for the x values, it goes from -5 to 0. Those are where the graph is contained between those two numbers as ordered pairs. Okay, the y value is your range. Your range, this is your y-axis, okay? So we're going to be looking at numbers on the y-axis. So the smallest number you see on the y-axis is down here at -4, and at -4 we have a solid point, so I'll put a bracket at -4, and it goes all the way up to, you see an open circle at the 5, so we'll put 5 and then a parenthesis. To determine if this is a function, you're going to do the vertical line test. We did this on day 1 to tell if something's a function. Can you draw a vertical line through anywhere on the graph, and there's only one point on each vertical line? So in this case, yep, there's one point on each vertical line that you see, so yes, it is a function. Let's try the next one. Again, domain is your x value, so I would say it goes from this point here to the farthest it goes. This direction would stop right there. So I would circle, it goes from -5 to +3. The graph is between those two boundaries. So then you look, okay, is it a closed circle or an open circle? At -5 we have a closed circle. So I'm going to put a bracket at -5. At 3 we have a solid line. It's not an open circle or anything, so I'll say at 3 I'm also going to put a bracket. Then you want to do your y values, your range values. So range, it looks like if I go over here, the lowest it goes is here, and the highest it goes is there. The whole graph is between those 2 points. If I colored in this part of the graph, they're between those two numbers. So at -3, it's going to be a solid dot, meaning if I drew this over, dot, 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 at -3 here, that's a solid dot. Vertically, the highest point the graph gets to is +3, and that's a solid dot. So I'd say it goes from -3 to +3 on the y-axis. Remember, this is my y values. This is your x values. So I've highlighted in the picture, where do they go from? So now you do the vertical line test. Is this a function? So you check all vertical lines. Okay, this one has 1, 1, 1, 1, 1. Then I get to this one and see how there's 2 points on that vertical line. So this is not a function. 2 points on a vertical line. So that is why it's not a function. We have 2 points on that line, there's 2 points on this line, and so forth. So if you have more than 1 point on a line, that makes it not a function. Let's go to the next page. So again, just working with identifying, is it open circle, or is it a bracket or a parenthesis? So on this one, again, looking at the x-axis here, this is our x values. The whole graph goes from this number to this number. This graph is between the numbers -2 to 4. So let's think about it. At -2, we have an open circle. Technically, it's on the line. So, since these are all points at -2, those would be solid points. So I'm going to say it's a bracket at -2 to a parenthesis at 4. Again, I'm talking on the ones that I have highlighted yellow. Domain is your x values. So that goes from -2 to 4. I know that's an open circle, but if you look under it, here would be other points on that same line that are darkened, so I would use a closed bracket. Now let's look at our y values, our range values. Remember, you always start with the lowest number first, so negative 2 is my lowest number, and 5 would be my highest number. It's between those two lines. I'm going to say negative 2 is the lowest, and 5 is the highest. And at 5, I'm going to put a parenthesis. There's no other points at 5, just an open circle, whereas here there's other points at negative 2 that would be filled in, so that's why I put a bracket there. So let's do our vertical line test. There are multiple points on that line, so that makes it not a function. So same kind of problem, only this time instead of circles at the end, we have arrows on some of these. Remember, an arrow represents a parenthesis on that end. And the other thing is, if it's going towards negative numbers, I'm going to put an arrow towards negative numbers. Then you're going to use negative infinity. It's going to go on forever, but it's going on forever towards negative infinity if the numbers are negative. If it's going arrows pointing toward positive numbers, then it's going to equal a positive infinity. Okay, so going towards negatives is negative infinity, going towards positives would be positive infinity. Alright, let's look at a picture and apply that. Still the same idea, domain is left to right, so the farthest it goes left, it looks like is negative 4, but if you notice at the end of that, it has an arrow. Farthest it goes to the right is at 5, so I'm going to say at negative 4, since it had an arrow going negative, I'm going to say it goes to negative infinity, but at the number 5, it has a closed circle, so we'll say that's 5 with a bracket. Now let's look at our range. The range is the y value. The lowest point it looks like it goes to right here is negative 5, but again I have an arrow at negative 5. The highest point it looks like it gets to here is 2. So I'm going to say, since it's negative going negative, it keeps going, that'll be negative infinity to positive 2, and at 2 we have a solid dot, so I'll put a bracket. Is this a function? So let's do the vertical line test. Every vertical line has 1 point. So I would say, yes, that is a function. Okay. Domain. Farthest we go left is negative 4. The farthest we go to the right looks like 2, but then you'll notice at 2 it has an arrow. So, open circle means a parenthesis. So we'll do a parenthesis at negative 4. But then at 2 it's going to keep going. So I'm going to say it goes to infinity. Infinity, it goes on forever and it's going towards positive numbers. Range is your y value. So the lowest number it gets to, it looks like here, is negative 1. The highest number looks like 5, but since that's an arrow on the end, it's going to keep going on forever. I'm going to say at negative 1 is the open circle, but since it goes on forever, we'll say infinity. Now we do the vertical line test. Let's see. Point, 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 point. Okay, so 1 on each of those lines makes yes, it is a function. Alright, let's see this one. This one you'll notice has arrows on both ends. So at negative 4, it's going to keep going negative. So on that end, I'm going to say it's going to go to negative infinity. On this end, it's going to the right at 5, but it's got an arrow going that direction, so we'll say it goes to infinity. Alright, let's look at our range. Range is up and down, So let's see, down here at -4, it's going to go down, and at 3, it's going to keep going up. So we're going to use the same thing, negative infinity to infinity. It's going on both directions, negative-wise and positive-wise. So, is this one a function? And the idea, there's no vertical line that you can see that has more than one point on it. So yes, it is a function. Alright, hang in there guys. So, recap. Open circle is a parenthesis. An arrow is a parenthesis. If it has a closed dot at the end, like this one has a closed circle, that's a bracket at that point. Okay? Alright, some people like to look at this point as the point 5, 2. So the x value is 5 and the y value is 2. So that was our ending point, was 5 for the x and 2 for the y. Another way to kind of figure out where do they end at or where does it start at. Alright. Determine whether the following is a function, circle yes or no, state the domain and range. So this is a little bit of a review of what we did last time with is it a function. We determined if it was a function if the x's don't repeat. So x's can't repeat for it to be a function. So I'm going to highlight all the x's. X's are the first numbers in the parentheses. Okay, so out of all those numbers that are highlighted, x does not repeat at all. So I'm going to say yes, it's a function, and then list them. Well, my domain would be all the ones that you see. At the bottom we have a little hint to remind you what we talked about last time. You want to list from least to greatest. And do not repeat numbers. So like if you have 2 of the same number, you only have to write it down once. Okay? Alright, so let's go back up here. These are all my x values highlighted. The smallest x value would be -1. So we're going to go -1, and then 0, 3, and 4. So those are all my x values. Sometimes you'll see them written out like that. Sometimes people put these little brackets on the end of that. They're saying those are your x values, those are your domain numbers, your input values. The range, so I'll just write that to the side, x values. The range is the y values. So all the numbers left would be our y's. 2, 2, 5, 3. So least to greatest, 2, 3, and 5. So again, this one had 2 number 2's, and if they have the same number, you only have to write it once. Okay? The difference between these and the last ones we were doing is these are just single ordered pair points, just single points, whereas the other ones were continuous lines. So with continuous lines, if we look back, with lines or things that connect the points here, then you have to use these brackets and parentheses 6. If you just have ordered pairs listed out, you literally list out your domain and range with order, each the x's and the y's. So you're going to look at the top line here, the x values. Do any of those repeat? So all of those are different numbers, so I'm going to say yes, it's a function. Now I want to list my x's, my domains, from least to greatest, which they happen to already be in. Then you're going to list your y's from least to greatest. Looks like -5, -2, 1, and 4. Okay. These are a little bit harder to see, so I'm going to just kind of make my points a little bit darker. So if I look at all those points, there are no 2 points on the same vertical line. So all these are on different lines, so I'll say yes, it's a function. I'm going to write down the ordered pairs next to them. So like point A is at 2, 7. Point F is at 7, 7, negative 5. E is at 0, 2. B is at negative 4, 6. And D is at negative 3, negative 3. Okay, the reason I wrote down all those ordered pairs is so now I can pick out, okay, out of those, what would be your x values? So your x values, the smallest one, or the furthest one this way, is negative 4, and negative 3, 0, 2, and 7. Then you're going to look at your y values. The lowest y value looks like we have is at negative 5, and negative 3, 2, 6, and 7. So ordered pairs, you have to figure out what are the ordered pairs so you can put the x's on the x line and the range, the y's on the y line. On an input-output table, this is called a mapping. This is your x values, or your domain. The output values are your y values, which is called the range. So with the mapping, you want to make sure the x's don't repeat, which means the x's can't have 2 arrows. If you look at this number 0, it has 2 arrows going off of it. So if it has 2 arrows coming off of it, it is not a function. So now let's go ahead and list out our domain would be our x's. 0, 1, 2, 3. Your range is your y values, negative 2, 1, 2, and 4. So, if you have a picture like this one where there's continuous line, then you will be using the brackets and parentheses, okay? If you have ones like this where numbers are listed out individually or points are not connected, anytime you have a list of numbers, you write the numbers each down. But if you have a continuous line like these, this is when we have brackets and parentheses, okay? Brackets and parentheses. Parentheses are for open circles or arrows like infinity. Brackets are for closed circle, or like in this case right here we had a solid line there. If you have a solid line, that would be a bracket. That is everything with domain and range. Remember to list them if you have to list them out, least to greatest. And we don't put repeating numbers if there's anything repeats in your domain and range.